And our first speaker is Wei Wang from the University of Electronic Science and Technology of China. And he's going to give a talk on decoding neural activity into language. Wei, do you want to start sharing your screen?
Okay, I will speech my reports. Are you okay?
Yes, I can hear you. Do you have can you share your screen?
Are you see my screen?
I see the PowerPoint window. So if you start your presentation.
Okay. Okay. Hello, everyone. My report title is translating neural activity into language. Our purpose is to decode language from visual neural activity. Okay, first about the experiment. First, we did two experiments. One is a retinal topic experiment, and another one is image watching experiment. The purpose of the first experiment is to locate the visual cortex area. The purpose of the second is to decode the text based on the neural activity induced by the nature image. Okay, based on the results of the first experiment, we managed to get the location of visual areas for each subject. This is V1, V2, V3, and VC. Okay, VC. Okay. Next, one of the central part of my research is to construct a language decoding model based on the visual areas fMRI activity. Only through this model we can decode a phrase or sentences from visual fMRI activity. Okay, this is the text result in the picture. The picture contains the nature image and file text from annotators. At the bottom, the blue sentence is the decoded text from fMRI activity. fMRI activity decoded text. Okay, as we can see from this picture, we use three evolution indicators. Three indicators. Okay. To evaluate the performance of language decoding. Look here. Look here. The blue bar signifies the average score between the generate text and the annotated text from the testing set. And the gray bar signifies the average score between the generated text in the testing set and or annotated text in the training set. Okay. Next, we do another important exercise here. As we will know, the fMRI activity has HR have proper test. Therefore, we use 14 alphas as the weights of the 40-time visual response patterns to observe the time distribution for contribute to language decoding. And the sixth interesting finding is that for language decoding, the time distribution of different visual is different. V1, V2, V3 time distribution is different. Okay, LVC, HVC, and VC is different. Okay, and thank you. Thanks for listening. My is over. Okay, thank you.
Thank you. So I'm going to give you applause because we can't do this, but please use the chat to put in your reactions for Wei's talk. And please use the Q&A or the YouTube chat or the general chat for your questions. So I have a quick, maybe a silly question. So was this trained on English text? So was this predicting English text only, or can you predict other languages as well?
Can you type? My English is poor, so. Okay. Yes, I can from visual activity decode into Chinese or Japanese.
Okay. And does that work equally well?
I haven't broken it down yet. I'm sorry.
No, that's fine. Let me ask a different question. So you're using the visual information, the visual areas of the brain, but have you thought about using higher level or more semantic areas of the brain as well?
Semantic brain. Can you type?
I just sent you the question.
I want to use areas. I want to, but I don't. I didn't these other areas fMRI activity.
Thank you.
Okay, thank you.
All right, I can't see any other questions. So if you have a remaining outstanding question for Wei Wang, then please put it, you can still put it in chat or in the Q&A. So Wei will stick around and can answer questions for you. So thank you again, Wei.